Alright, read the question, give it a try and then proceed further. A car overtakes a bike at point A at 8 am. The car reaches point B at 10 am and immediately turns back. It again meets the bike at point C at 10:30 am. At what time will the bike reach B? Okay, so we have a point A at which the car overtakes the bike. Car overtakes the bike. And the car reaches point B at 10 am and returns from this point B and meets the bike again at this point C at 10:30 am. Okay. The bike meanwhile will be covering this distance AC. So this is the scenario here. Nothing is said about change in speed. So we are going to assume a constant speed as B for bike and as C for car. Okay, car is also driving at the constant speed. Even after turning back from B, the car is driving at the same constant speed as before. Okay, so first case is when car drives from A to B and second case is when car drives from B to C. Speed of car is constant in both the cases and time is given. In this first case, car is overtaking the bike at 8 am and car is reaching B at 10 am. The time taken is 2 hours. In this second case, from B to C, the time taken is half hour. Okay, this time is 2 hours. Time taken is half hour or T2 is equal to 0.5 hour. Okay. And speed throughout this journey from A to B and from B to C, speed of car is same. Speed of car is constant in these two scenarios. So we can say in these two scenarios, time would be directly proportional to distance or distance would be directly proportional to time. Ratio of time is T1 is to T2, which is 2 is to 0.5 or 4 is to 1. So ratio of distances T1 is to D2 will also be 4 is to 1. We can say AB is to BC. AB is to BC is 4 is to 1. AB is to BC is 4 is to 1. That means AC is to CB would be 3 is to 1. Okay, this BC part is 1, AB part is 4. That means AC part would be 3. AC is to CB is 3 is to 1. Now the bike takes 2.5 hours to travel from A to C. Okay, from 8 am till 10:30 am, the bike takes 2.5 hours. So to travel from C to B, let's calculate the time bike is going to take to travel from C to B. Again, the bike is running at a constant speed from A to C and from C to B. First case would be bike running from A to C and second case would be bike running from C to B. So in this first case, in both the cases, speed of bike is constant. So we can say time would be directly proportional to distance. If time taken here is T1, that is 2.5 hours. Time taken here is T2, that we have to calculate. Distance from A to C and C to B, the ratio of distances is 3 is to 1. So distance is directly proportional to time. So 3 upon 1 will be equal to 2.5, that is T1 upon T2. Ratio of distance will be same as ratio of time. From here we can easily calculate T2 as 2.5 hour upon 3, that would be 150 minutes upon 3 or 50 minutes. So time taken by bike in order to reach from C to B is 50 minutes. 50 minutes after 10:30 am would be 11:20 am. Okay, 10:30 am plus 50 minutes would be 11:20 am. That's the time when bike reaches point B. Next question. Just pause and go through this question. It's a classic question that you will come across in this topic. a train meets with an accident and travels at 3/4 of its regular speed hereafter. So if this is the point when the train meets the accident, after this point the train is going to run at 3/4 of its regular speed. So till this point the train was running at regular speed, and after this point train is running at reduced speed. Okay, and it reaches destination 45 minutes late. If the accident occurred at this point in place of this, the train would have reached 35 minutes late. Instead of 45 minutes, train would have reached now 35 minutes late. We have to find the regular speed of train. So we have two scenarios. In both the scenarios, the train is covering same distance. Okay, from starting till end, train is covering same distance. So we can say distance is constant in these two scenarios and speed would be inversely proportional to time. In both the scenarios, the time difference with which train reaches is 10 minutes. In first case, train is 45 minutes late. In second case, it is 35 minutes late. So difference in time in which train reaches is 10 minutes. Now, why is this difference of 10 minutes coming? Till this point, in both the cases, train is running at a regular speed. Okay. In first case, after this point, train is running at a reduced speed. In this second case, accident happens at this point. After this point, train is running at a reduced speed. Till this point, train is running at a regular speed. So, before this point and after this point, the situation is same in both the cases. The difference of 10 minutes is coming due to this patch of 10 kilometers. Okay. So now the question is easy. Let me take this last solved example of the previous video. Focus on these 10 kilometers. Here the speed is normal. Okay. Here the speed is normal for this patch of 10 kilometer. In the second case, the speed is normal. Let's say the speed is S. In this first case, the speed has become reduced speed. The speed has become 3/4 of its regular speed. So the speed here is 3/4 S. As the speed and time are inversely proportional, here the time will become 4/3 of the original time. If the time taken here is t, here the time will become 4/3t. Right? Now 4/3t means an increment of 1/3 over 1. Okay, increment of t/3 over t. So 1/3 increment in original time is given as 10 minutes. Right? 1/3 increment in original time is given as 10 minutes. So t/3 is equal to 10 and t will come out to be 30 minutes. We want the regular speed of the train. That would be distance upon time. This patch is of 10 kilometers and time t is 30 minutes or 1/2 hours. So regular speed would be 10 upon time, that is 1/2. This is 20 kilometers per hour. Well, what will be the total distance? We don't know. We don't have total time. We just have delay in times. So with only speed being known, we cannot calculate the total distance. I hope you enjoyed this video. I hope you enjoyed solving these questions. Thank you.